Okie dokie. Today, your objective is the students will learn to distinguish between permutations and combinations. So we haven't talked yet about combinations. In order to use the fundamental counting principle to predict the number of desired outcomes of the event. Okay? So remember, permutations are picky, and you're going to see the difference between a permutation and a combination today. The steps are going to be very similar, but you have different buttons on your calculator. So we are working on page 6 in your packet for today's notes. You could use this formula, but it's going to be much easier to use your calculator. In a combination, the order makes no difference, so that's the main difference. Makes no difference. Remember, permutations are picky, and you have a specific order or a specific thing something has to go in. Okay? And just like permutations, no item is used more than once, so you're not repeating anything. No item used more than once. Okay? All right. So the big thing with this unit is the math is not that hard, but you have to make sure you're using the correct formula. So as you're reading through this problem, we have the stipulation that we are only choosing 4 artists to perform. And none of the artists are divas and care what order they perform. So there's going to be something in the problem that tells you whether or not the order matters. You just have to interpret it. So very similar to what we did last class, you start with your n. N is the total number, and R is what you're going to choose from. So how many you choose or how many you need. So in this case, our n would be the total number of performers, which is 6, and we only are choosing 4. So this you're going to have to use your calculator for. You're not going to do 6 times 5 times 3 times 2. You're going to do 6 NCR 4. So if you need a refresher on how to do that on your calculator, you do 6 math button PRB. So you go over to PRB, and then you go down this time to NCR, and we would put 4. You might have to hit enter in between there, and then enter. Okay? So I believe you'd probably have to do enter 4, enter. Okay? If you do that, you should get 720. So 720 combinations. Okay? All right, next one. 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many committees can be formed? So what makes this a combination is it's just a 3-person committee. It doesn't say, like last time, you have a vice president, president, treasurer, all that stuff. All you need is 3 people, any combination of 3 people. So n is the total number. We have 6 people to choose from, but we only need 3. So on our calculators, we do 6 NCR to get us, make sure you know how to do that. If you don't, please ask. And you get 20. Okay? All right, moving on down. Baskin-Robbins, not my favorite ice cream spot. Apparently they have 31 different flavors of ice cream. One of them is a bowl which has 3 scoops of ice cream. How many such bowls are possible? So this is a combination because it doesn't say your order matters. It doesn't say you have to have a specific order on the top, one in the middle. So So you have 31 flavors, and then you're picking 3 flavors for your scoops. So N equals 31, R equals 3, and you would need to calculate this. Okay? Next one. You are selecting 6 DVDs from a list of 200. So what makes this not a permutation is you're just selecting 6. It doesn't say you have a least favorite, a favorite, or anything in between. So you just need 6. So hopefully you can figure out what your N is and what your R is, and then how many ways you can do this. Okay? You can skip question 5. If you actually read through it, you'll see that there's really no mathematical question on it. My B. All right. Moving on to the back. The back is just a review of permutations or combinations. Remember, combination is no order. You're going to see words like committees, just selecting, permutations are picky, so order matters. So you might see like first, second, third, like first, second, third, favorite to least favorite, president, vice president, okay? So what you need to do here is you need to decide if each one is a combination or a permutation. So what I'm going to do is I'm going to read through the problem, and I'm going to highlight what kind of clues you in on whether it's a permutation or a combination. Race, there's 50 runners, no ties. How many ways can the first 3 finishers come in? Okay, so in this case, you have that first, second, or third. So it's a permutation. N is the total number of runners, and you need 3. And then you need to do your answers or your solution. So if it's a permutation, you could just do 50 times 49 times 48. Or, I think the easier way is to just use your calculator to do 50p3, and then we'll be around to look for your answer. I suggest just doing it on your calculator. All right. Next, you volunteered a pet sit for your friend who has 7 different animals. How many pet combinations are possible? So pet combinations clues you in right there that it's a combination. You have 7 animals. You only need 3 to come with you. So you would have to do, you can't do 7 times 6 times 5. So you can't do that because it's a combination. So 7, choose 3. And that should give you your answer. All right, so what you need to do is 3 and 4. I'm going to highlight the key words that will clue you in on whether it's a permutation or combination. Okie dokie, so you need to get page 7 done in your packet, and then an additional part of this video is on the classwork that you need to go pick up right when you finish page 7. This part of the classwork is covered here, where we're using combinations and the fundamental counting principle. All right, so it'll be very helpful if you have two highlighters, because we're gonna, in all of these scenarios, you're gonna have two different categories. So in this example, we have Republicans, which I'm gonna do one color, and we have Democrats, which I'm gonna do a different color. So the way you know to use this method is if you have two categories of something. So we're going to use combinations first, because we want to figure out how many committees can be formed if we need 3 Republicans and 2 Democrats. So you use combinations first. So you should see that for Republicans, the total number of Republicans is 54, and we need 3 of them. So we're going to do 54, choose 3. Hopefully you get this number on your calculator. For Democrats, we have 46. We need 2 of them. So you use your combinations. Hopefully you get this number. Okay? So that's the first step. This is a kind of multi-step problem. Now what you're going to do is use the fundamental counting principle, and you just multiply those 2 numbers together, and the very large number is your answer. Okay? So again, in all of these types of problems where you use both NCR and the fundamental counting principle, you will have 2 separate categories, which I suggest highlighting 2 separate colors. So on this one, you have your mathematics exam of 10 multiple choice questions, so that's going to be a color, and 5 open-ended problems. If you take the test, you really it says you only have to answer 8 of the multiple choice, so you get to choose which 8 you answer. Whoops. And you only need to answer 3 of the open-ended questions. So I've kind of color-coded multiple choice together. So multiple choice, you have 10 questions to choose from. You only have to do 8. So there's 45 different combinations you can do. Open-ended, you have 5 questions to choose from. You only need to do 3 of them. So you have 10 options there. And from here, you're going to use the fundamental counting principle. Okay, so you're going to do 45 times 10 and get 450. Okay? So if you need to, it might be a good idea to circle the numbers that you use to multiply in your examples, because there are going to be a lot of numbers on your paper. All right, so your goal is to finish your classwork assignment, and then we are going to do our closure, so you need to be ready for that. I will be around to answer any questions you have. Bam! Got it done.
Noise.
Oh, wait, I didn't stop it, Brandon.